action. I think that was action. I don't know. Anyway, you all copy this guy down, right? Now I've thrown every, monkey wrench into this that I could, that I think you might see as a mistake. Okay. The other, if you think about the examples, it's the third example we're doing. The first one was the easiest. You don't even realize all the ways it was the easiest, but one of the big ways was it didn't require us to use the quadratic formula. This guy's harder for multiple reasons. First of all, do you notice something right off the bat? What do you notice?
It's actually
it's not A, B, C. There's grams.
Okay. I hear two things out there, and they're both correct. Grams instead of moles. That's a problem. I don't have just ABCs to make life easy. I have actual things. Do you see something else about those things I actually have?
They're not all gases.
They're not all gases. That's a biggie. And what Des said in the back is absolutely true. I didn't give you a reactant. I actually gave you a product. All of this stuff makes this problem that much weirder and harder to do. So let's start with, and I'm going to probably end up erasing this too. You know we're going to write the ice here, so you want to leave yourself the space, but you also need to show this. We'll set up ice at least here. I-C-E. But you know I'm going to have to change my grams to moles first, and then also remember the size of the container. So let's do that. I made the numbers relatively easy that we could do them in our heads, okay, for the most part, some of these. Okay? You ready? So I want to find out what I have. I'm told I got 14 grams of carbon monoxide. That's this guy over here. 14 grams. I'm going to convert that to moles. Everybody agree? Grams on the bottom, moles on the top of carbon monoxide. I made it nice and easy. Carbon and oxygen, 12 and 16 about is what? 12 and 16? 28. All right, so 14 divided by 28 comes out to be a relatively easy number. What's that going to be? Yeah, 1/2 or 0.500 moles. However, that's moles. That's not molarity. It's a 2.5 liter container. 5 divided by a 2.50 liter container gives me, do that quickly. What's that? What is it? 0.2. So I kept some relatively easy numbers to use. And I know I have 0.200 more. So there's your first problem with that. I am going to erase that, so make sure you have that copy first. Because I need, as you know, with Smartboard, I don't have a whole lot of room here, and I want to show it all on the TV. So, TV? Anybody watch this on TV? Seriously? on the internets. On the internets. On the World Wide Web. That's where we're going to be. All right. So where's this guy going to go? He's going to go up here, 0.200 molar. That's weird too. Let's erase. Now I'm going to erase because I want to come back. That was just my conversions to get my molarity. So I'm going to erase this out of the way so we don't have that here anymore. All right. Now, that's a problem. I'm told I put him into the container. How much C and CO2 do I have initially then?
0.
Yeah. So that's a problem. All right. Most of you guys are into linear thinking. And so we read, we're English, so we read from left to right. So we're used to things going from left to right. If I put 0.2 molars of this into here and none of that, is it going to be minus x, and plus 2x over here? Does that make any sense? No. It's going to be minus 2x, plus x, and plus x. You've got to get rid of that linear thinking when you're talking about equilibrium problems, because they can go both ways. Okay? All right. So at equilibrium, I'll have x, and 0.200 minus 2x. Got that? All right. So now it's starting to look kind of like a regular problem. Yeah, perfect timing. Something can go wrong. Starting to look like a regular problem. Don't worry about, leave them there. Just let them go. Keep watching this, because Kc is going to equal products over reactants. You need to write the equation down. This is going to become a problem for some of you guys. You want to just jump ahead and start throwing things around in terms of x. If you don't do this step, I won't be able to give you partial credit. It's products over reactants. Okay? Hold on a second. Okay. All right, now look it. It's not products over all the reactants. Remember, if you've got a pure solid or liquid, he's not included in the rate locks in the equilibrium expression. So it's just going to be CO squared over CO2. You see, I leave out carbon there from that expression because he's a pure solid. And we only include molarities. We only include things that are either aqueous solutions or gases filling up a container. All right, now let's throw our numbers in and x's and stuff. We know Kc is 10. We know the CO is 0.200 minus 2x. We know CO2 is x. And we have to square that guy as well, don't forget.
Mr. Allen?
Yeah.
How is CO a product when it's going to be?
The equilibrium expression is set up for that equation. CO is the product. He is the product set up in this equation. It doesn't mean that when I add I can't add a product and have it go the opposite way. That's why I said about getting rid of the linear thinking. I could have written the equation backwards. All right, if I wrote the equation backwards, the difference would be that Kc would have been 0.10. Okay, it would not have been the same Kc. So he is a product. That is what we call the product. This is what we call the reactants for this equilibrium expression. But I can add a product and have it go that way to begin with. I know it seems weird because you say to yourself, well, doesn't that just make him the reactants? Well, I guess technically you could do that if you want to inverse Kc, but we're not going to do that. All right. Anyway, so we all good with what we're doing here. All right, so far, so good. Now, what do we have to do? Well, we got to do two things. We got to cross multiply, and we have to get this guy into a quadratic formula. So we'll have, what, 10x equals. Now, when you square a binomial, by the way, there is a shortened way to do that. Do you guys know what you could do? Square the first, 2 times the first times the second, and square the second. That's all you really have to do, right? It's true. What's the square of the first? What's 0.2 times 0.2? 0.04, I believe, right? Is that right? 2 times the first times the second is 2 times 2 times 2 is basically 8, and there's a point in there, so it'd be 0.8. Is that right? Do that on a calculator. Make sure that's right. I think it's going to be a negative 0.800x. Is that correct? I tried to make numbers relatively simple that they would work out, kind of doing them in the head. Now, the last one, I know I could do that in my head. What's 2x quantity squared? Negative 2x squared? Positive 4x squared. Okay, did we go with that? Oh, yeah, okay, I got the x there, good. And that's a plus sign here. Everybody good? Everybody can all see that. Now, I got to bring all of, again, to one side. Which side do I want to bring it to? I want to bring it to the x squared function. The x squared variable is positive. So I'm going to keep it on this side. So it'll be 4x squared. Bringing this guy over makes him negative. That means that minus 10.8x. That guy stays the same, plus 0.0400, and the whole thing equals 0. Is that good? Make sure I'm not making a mistake, because you know I'm very good at it. I made pretty much every mistake we could possibly make in the first period, and then compounded that with the calculators. All right, we know what this means. This means ax squared plus bx plus c equals 0. Grab your calculators, get the program, and see what happens.
Should 10.8x be positive?
I brought the 10x over to that side and made them negative, right? It's a positive. I subtracted from both sides,
Okay.
right? So that's why he's negative. And I brought him over to the other side. Okay, so it's ax squared plus bx plus c. Plug in a and b, and tell me what your two roots are.
2.696.
2.69, and what else? 0.003711. Okay. All right. Now, those are your two possibilities. Which of those roots? X equals one of those two guys. Okay. Notice there's no obvious. Everything's in this one, guys. Everything. It was obvious which root to ignore last time, wasn't it? Because it was negative. But it's actually still obvious which root to ignore this time if you think in chemistry and not just math. Okay? If you're not just thinking about math. Chemistry, let's plug that guy back in here. Okay? This guy, this 2.69. If I plug in 2.69 over here and here, you say, okay, whatever, that's fine. But can I plug it into here and make sense? No. I'd be saying I added 0.2 molar of CO into the container. And then I'm going to subtract 2.6, actually 5 point something from that. I'm going to end up with less than 0. Less than 0 in that container of the CO. I can't do that. I can't end up with less than 0. This is real life. Okay? So I'm going to ignore this one and use that guy. Now, what did the question ask me for? Let's go back to the question, see what it was asking. I didn't want everybody. It just wanted one guy. Who did it want? We want to know how many moles of CO will actually remain at equilibrium. Well, how many will be there at equilibrium? Okay, so what are you going to have to do with that 0.00371? Plug it into here. So basically, CO, I'm running out of room here, CO is going to equal 0.200 minus 2x. So it's going to equal 0.200 minus 2 times 0.00371. Give me that answer. Can't do that in my head. Can't do most of these in my head, but anyway. Don't forget to times it by 2.
0.193.
0.193 molar, right? Or molar, yeah, molar. But 193 molar. But if I want to know how many moles were left, people, there's one more thing I have to do. Yeah, there's actually a 2.5 liter container. So I actually have to take that one. I'm totally out of room now. I'm just going to erase over here. Just erase this over here again. Okay. All right. And I'm going to take that 1.93 moles per liter and multiply, because remember, molar means moles per liter, right? And I'm going to multiply by how many liters I have, 2.50 liters, and I'm going to get how many moles of CO are left in that container.
It's 0.193.
How much?
Point.
Oh, I'm sorry, I said 1.93. It's supposed to be 0.193. Okay, 0.193 times 2.5. What do you get? 0.483 moles of CO are left in the container. That is as tough as it gets, in my opinion. You had to convert from grams to moles in the beginning. You had to remember to go the correct way. You have a guy that's not a perfect square. You know, you have him 2, and you're going to have to square him over here. You got to use the quadratic formula. You got to use your equation, and then at the end, you're still not done when you get the x, because you got to plug them back in up here, and then you're still not done because you got to remember the size of the container. There's just so many things to remember in a problem like this. It's a pain in the neck, I know, but there it is. That's as hard as they get, luckily. We are going to do some other things in the near future, like tomorrow, but I'm going to give you the rest of this period to work on the rest of those problems over there. Okay.